Okay, everybody, I think we're going to get started. It's 3:38. We're just a couple minutes behind the schedule. Elise or Dawn, are there any announcements you want to make before we get started? No? Okay, this is hands-on session number 2. And I'm going to lead you through some data visualization of, oh, hi, everybody. I don't know why I assume you know who I am. My name is Jackie Parody, and I am an astronomer. I work at the American Museum of Natural History. I actually do a lot of work on data visualization because I work within a planetarium, and you will reap the benefits of that tomorrow. If I could just give a slight plug for another, it's not quite a hands-on workshop. It's not a hands-on session, but it's a demonstration of a true visualization tool, a true three-dimensional visualization tool using this planetarium software that we have called OpenSpace. So it's going to be tomorrow at 11:30. So before lunch, you're going to get to see a master's student from Sweden who is going to be signing on, which is basically the middle of the night for her. But she really wants to show off this tool, a true data visualization tool, and something that we use in the planetarium. But in thinking about what we could do for everybody here for deep diving into Gaia data, one of the kind of baby steps into the pool that I thought would be a good idea to go through with everyone, and I don't even think it's that much baby steps, I use it every day as a researcher, is to use a tool like glue. So I'm curious, both from those that are in the room and anyone at home, how many people even know what I'm talking about, what GlueViz is, or have you ever used GlueViz? Just a show of hands. Anthony has. We've got 2, maybe 3. Tentative hand coming up. Maybe a couple more tentatives. I didn't see anybody's hand shoot up. So I'm feeling like we're gonna go through this a little bit slowly so that everybody can get on this. For those of you that are on the virtual, you could say in Slack if you've ever used it. If you did feel like you're a glue expert, you can kind of zip through some of the steps that are on the Sagan workshop website. I have placed on there a document that takes you through very, very, very careful step-by-steps of part 1, part 2 in using GlueViz, in digging through the data, just to dive right in to play with Gaia DR3 data, just Gaia DR3 data, and then Gaia DR3 data with the Exoplanet Archive. But to get started, I'm going to give you guys like 3 or 4 minutes on what this tool is, and then we're going to, hopefully everybody will have it on their laptops, and we're going to go through a couple of steps. We're going to build up to making color magnitude diagrams, lassoing objects that we want to create subsets of, playing, having fun, doing science, making discoveries. All right. So this is the website. Glue it's an open source Python library. And the intention, which really comes from the brainchild of Alyssa Goodman, who is a legend in science visualization. She is at Harvard. She is amazing. She works on Worldwide Telescope. She works on Glue. She works on other visualization tools that try and make our lives as astronomers easier. And Glue is a product of that. It's to explore relationships within and between related data sets. At the very basic level of what we're going to go through right now, it's like TopCat. How many people have used TopCat? I see a lot more hands shooting up. Okay. If you're familiar with TopCat, this is going to get you right into it. This is like TopCat on fire. That's how I think of it. It's a very fiery kind of TopCat. But this is a plugin, and so it can work within other tools. So for instance, this can actually work within the Worldwide Telescope frame structure, and the tool that you're going to see tomorrow that this master's student, Emma Brahman, is going to show you, called OpenSpace. We've actually built a portal so that you can go straight from Glue into OpenSpace, straight into a full frame dome, a planetarium, which is something that I would be happy to do someday for anyone that wants to come to New York City and visit me at the Hayden Planetarium. But so glue is very powerful, but we're going to just go through a couple of, we're going to go through the basics today. You hopefully have installed it so that you have it on your machine. If not, there are two different ways that you can do it. And again, it's linked on the Sagan workshop on how to download the GUI, just a nice simple GUI for your Mac. And looking around this room, I see the majority of people are doing the astronomer thing. We've all got some Macs in here. You can just put it as a desktop utility, or you can install it via Anaconda. It's a more powerful tool when you do it that way. We're not going to run into those more powerful aspects of it, but you can certainly get into a scripting capability for this later if you get super into it. On the website, glueviz.org, you can kind of scroll down. You can watch a 2-minute video, which explains glue in more detail than what I'm going to take you through today. It is a tool of choice for the James Webb Space Telescope. You'll be seeing it a lot more in demonstrating, contextualizing JWST data. So the website itself has more information on it, as well as tutorials that'll take you through how to get through some steps. Okay, but let's go through part one. I'm going to start with just a simple. We're going to start by playing with a Gaia DR2 sample. I don't want to jump into DR3 yet because it's harder. We're going to build up to DR3, but let's just play with DR2 data first. And specifically, we're going to stick with a distance limit that Todd Henry gave everybody on day one. Todd said, do you guys remember the distance that Todd told you to stay within for exoplanets? 100 parsecs. Yeah, people were paying attention, Todd. They were listening. Nice. So we're going to stay within 100 parsecs. Does anybody know how many stars were within Gaia's 100 parsec sample? Oh, come on, Mamachek, you can't guess like that. I was hoping for some, jelly bean guessing. It's okay. So yeah, there's over 300,000 stars, and Mamachek almost nailed it. So, well done, genius. We know you know. I'm kidding. No, I'm not. So there's just over 300,000 stars in the Gaia catalog of nearby stars. Glue can handle that. It might be a little bit choppy for a sec or two, not necessarily Gaia catalog of nearby stars, but when we go to DR3, because it's got a lot more columns. So on the package that I shared with everybody on the site, you can see that there's these ancillary data sets that I had already loaded for you. So I've already downloaded for you the Gaia catalog of nearby stars. If you haven't loaded it yet, just put it on your desktop. And then let's open Glue. So I'll take you through the beginning of this step, and then I'll just give everybody a second or two to run through the first step, which is just load the Gaia catalog of nearby stars, see how to import it in Glue, and then let's make a plot. So I'm going to just launch Glue. I'm going to go straight from Anaconda. It'll take a second, and then it's up. And then I want you just to import wherever you placed that Gaia catalog of nearby stars. So you can either do that in the top here. You can see that there's all of these nice buttons to let you see. I'm just going to shift this down so it's below my zoom buttons. But you can see you can have export session, open session, and then import data. You can do it that way, or you can do it from the drop-down menu, file, open data set. I have dropped the Gaia catalog of nearby stars on my desktop, I think. Glue is very good at reading a variety of files. This one's a FITS file. It'll be able to take it right away. You could pull it in as a CSV file, as an ASCII file. However, you've exported it, as Anthony showed everybody how to do yesterday. All right, now Glue will have you drop this data in. You can see the data set is right there waiting for you. And this area here in Glue is the drag data to plot. This is your playground. You can think of it, your sandbox. You're going to grab that data. You're going to pull it over, and you're just going to drop it right in here in the drag data to plot. And then it's got a lot of choices for you as to how you want to plot whatever you're going to plot, whatever's in that file. Hopefully, you know. You can see you've got choices of a 1D histogram, a 1D profile, 2D image, 2D scatter, this thing I never use, dendrogram. Does anybody use that? I don't use that. Table viewer. Well, let's do a 2D scatter and let's click OK. And it just kind of grabs the first two columns. And right now that was RA and source ID. But what happens now is that you've got a lot of choices. Now you've got your plot up here, move it around in your playground in your little sandbox here. And then you have choices of how to play with the plot. And we'll go through that in a sec. But down here in the lower left-hand corner, for those of you on Zoom, you can just follow my mouse. You see you have plot options. And under plot options, it says 2D scatter. And you have your standard plotting stuff. So x-axis, let's just switch this and do an RA and dec plot. So let's switch this to RA in the x-axis, and let's switch this to dec in the y-axis. And let's look at that distribution of the Gaia catalog of nearby stars. Okay, so I'm going to give everybody a sec to do this on your own, but you can see very easy peasy. Just made our first plot in using Gaia, the catalog of nearby stars. You had a lot of choices. Oh, one thing I did want to show you is that when you do your drop-down menu here, this brings up every one of the possible columns that are in that file that I just gave you. So you can scroll through all of them, you know, as you scroll through anything. And Gaia catalog of nearby stars is a pretty compact, nice, light amount of columns for you to want to work with. You've got pretty standard stuff. You've got your position on the sky. You've got your distance. You've got your errors associated with that, as well as the motions and the errors associated with that. And then a number of other, I think, fairly self-explanatory columns in this particular menu. So I'll give everybody a sec. Plot this when I'm going to give you maybe 2 minutes to get this to this point on your own. And then I'm going to show you how you can do a little bit of extra on this plot. So everybody just pull in Gaia catalog of nearby stars and make the RA and dec distribution. Maybe 2 minutes on this. So this one should be very easy. If there are any questions, you can just ask. If anybody's having trouble with glue installing or anything, just raise your hand. I can help. Okay, hopefully everybody got that or close to get pretty close. Give me some sort of indication, maybe a thumbs up, maybe some thumbs up. Yes, people are good. Okay, added layer to this is that you can now use that third dimension in glue of color, something you could do in TopCat as well. So this is why it's very TopCat. It's just not all about the table. It's much more about the plotting and connecting plots to each other. So you can come over here to just below the plot layers, and you can see that you can change the color of this, which is currently just fixed, and you could set it to something else. And so let's just swap it to a linear color. And you can select what the attribute is that you'd like to color code it by. And an interesting one to play with for this particular set of the Gaia catalog of nearby stars is, in my opinion, the GCNS _ PROB, the probability that it is in fact a star within the distance that the Gaia catalog of nearby stars is capturing. So if you click that, what you can then change the color map to something that you can actually see a little bit better, because right now it's black and white. Verdis is very nice. It's also colorblind friendly. And so what you can see coming out, can everybody see, you're kind of making out some splotchiness here? Everybody on Zoom see this? Any idea what that is? The galactic plane, yeah. Is the galactic plane within 100 parsecs? Sure, yeah. But we probably shouldn't see like the shape of the galaxy so much. Just to give you an idea, this is from a paper that I wrote right when Gaia came out. I have a plot. This is a paper of what the 20 parsec sample of Gaia looked like. Just raw Gaia DR2. Love it, Anthony. Loved Gaia DR2. But I plotted this immediately trying to find, as Todd was pointing out, the closest discovery that Gaia was going to make that was going to be brand spanking new. And there was a lot of confusion within the galactic plane because it's very crowded in there. And so the astrometry is a little bit messier. So the 20 parsecs sample of Gaia used to have a very strong signature of the galactic plane. And just to highlight, this was a discovery that I made within, I don't know, it was very close to when Gaia came out. It was at 11 parsecs, just outside of 10 parsecs. L dwarf, maybe I'll talk about it another time. But great, so you know how to do this. So it gives you that leverage of color, super. All right, next step, part 2. Let's do some arithmetic and then add that to the plot. So now I want you to play with, at the top here, this is now moving on to part 2. It says chi-squared arithmetic attributes and the hot buttons at the top here. If you click that, this brings up for you, which is basically, it's all Python language. So you have to write it in like NumPy language. You can't just follow whatever you would do in Python within the scripts within Glue. And set it to, you only have one data set open right now. Sometimes you'll have multiple data sets open and you have to remember that you're going to select whatever the data set is that you want to do arithmetic on. And then you're going to click new arithmetic attribute. And I just want you to do the distance, like figure out the distance from the parallax. So let's write in distance here. You're going to have to name it something. So that's what we do at the top. And then you're going to do your mathematical expression. So we're going to do 1 over parallax, but our parallax is in milliarc seconds. So let's do 1,000 over, and then we're going to drop in whatever the parameter is we're going to do math on. So we're going to select parallax. It already tells us if you haven't done something correctly, it'll tell you right at the bottom in red there, incomplete or invalid syntax. That just means you did something wrong, and it might be the syntax that you're using. It's not in Python mode. It gets a little annoying when you have to do, you know, multiplication, exponents, blah, blah, blah. But, you know, for the most part, you figure it out and you can see examples of expressions here. Is it too small? Oh, how do I make it bigger? No, I don't think, can I hit, maybe I can hit this. I don't know if that'll do any, oh, let me try and insert this for, yeah. I'll try it, I don't know why I'm trying it that way. All right, so you enter it, you click OK. Now you've got a new arithmetic attribute. Make that as, maybe that's bigger in Zoom. And then let's drag and drop over here, and we're gonna make a 1D histogram this time. Click OK. Over here on the plot options, we can change the x-axis. Let's go to distance. And now we've got a histogram of our distance in parsecs. And so I'll give everybody a chance to play with that. Make sure you build up to the ability to see arithmetic attributes in here and building a histogram. Maybe a minute or so. I don't know how, and in the process, I could try and fix the Zoom a little bit more. Were people saying anything, Elise? Did they want it bigger? You were noticing. Oh, it's too small.
For the equation, because for the plot, it's probably okay.
Okay, yeah. It's
Yeah.
also just small text.
Yeah, but I know with Firefox and stuff, right, you can make this command plus and make it bigger, but
Yeah.
I know Google probably doesn't have that. Right?
No, I don't think it does because it's like a
Okay.
Python thing. Yeah.
But you have your instructions too. So.
Yeah, it is. And there's a video.
Yeah.
I tried to basically give them everything. All right, so maybe one more minute. If you have any questions, just raise your hand. I think it's pretty straightforward. Okay, I hope everybody feels good about making this the histogram, doing the arithmetic. Now let's move on to creating a color magnitude diagram. So from that, I'll actually let you guys take that on. If you remember the distance modulus equation, if you don't, it's in the notes. You'll need to once again drag and drop the data in, go into the arithmetic attributes. So this is going to be into part 3, and create the G minus. You can do G minus RP or BP minus RP. Personally, I go to G minus RP always because I work on the low mass end of things, and BP RP is not very helpful for us. So choose your color versus magnitude, make a color magnitude diagram, take a couple minutes to do it, and then I'll show you how to lasso around parameters and move between plots. So that's your next assignment, create the color magnitude diagram. Yeah, they want it on the plots. So there was a question about enabling the legend on the plot. And there is, if you wanted to do that for those person asking on Slack and anyone else, and the plot options, you'll see there's a legend button on the far right here. You can click it, you can click enable, and you've got all of your nice, whatever you want to play with, label size, box color. It should all be there for you. And it drops it right on the plot. Okay, one more thing. Already people look like they're getting the hang of it. And so I just want to show you now the lasso tool before we head into, you can explore now Gaia DR3 with all of its many other columns. So hopefully everybody got to the color magnitude diagram here. And then the other component that's really nice on this particular in using glue is that you can, within each one of the plots, they will interact with each other. So for instance, let's just pull over another 1D histogram over here. And the choice that I wanted you to make is over here on the x-axis to pull down the white dwarf probability. It's pretty obvious where the white dwarfs are for most people. I think most of us can identify them on this sequence down here, low below the main sequence. But the Gaia catalog of nearby stars does give you a probability distribution of a white dwarf being a possibility in the sample. So you can lasso within any of the plots right now, and they will interact within all of them. So let's start here in this 1D histogram of the white dwarf probability. And this particular one is a histogram. So you get a box. So I'm going to click on this box up here, and I'm going to grab everything that's 80% or 0.8 to 1 probability. I just grab and drag, let go, hit enter. And now it's showing me on my color magnitude diagram the location of all of those white dwarf probability greater than 0.8 here where I would expect them to be. On the color magnitude diagram, it shows me their distribution in RA and DEC, if that was a curiosity for you. It shows you where they are in their distribution in the distance. Any other plot that you drop from this data set it will have that subset highlighted. Now, this empowers you to go and do exploring across any of the parameters now that hopefully you've been learning about with Gaia DR3, because you're not limited to a two-dimensional plot. You can run around in every single plot you want to and move between them sort of fluidly as it's it allows you to move between parameters on any given plot very, very quickly and easily. So in this plot, I could go the other way. I could say, okay, I'm gonna lasso. You don't have to use just that lasso tool. You have on a scatter plot like this, you have more choices. You can go a little bit more Wild West and have a lasso region of interest. And so maybe you want to zoom in a little first. Maybe you want to grab all the giants so we can zoom in there and then use the free reign lasso tool. And let's grab what we think is maybe all the giants here, hit enter, and then look at their distribution. And so I think most of them are probably, there's not that many. They're really down low on this histogram. You can see them lit up in red. You now have the ability to work with them as a subset. And so for instance, if you were like, this is what I wanted that data set, I'm going to go play with that elsewhere, you could export it. And so you here now have that particular subset in your plot layers that you can turn on and off, and you can go to export, export data subsets. You would choose the catalog that you've been playing with. This is the one that you're working on. Choose the data that you want. You maybe just want your giants. You'd choose subset 1, all of the components, if that's what you want, including the ones that you already arithmetically derived. And then you would export it in whatever way you want to. Comma separated variable, FITS file, HDF5, VOT table, whatever you wanted. You'd export it, tell it where you want it to export it to, name it, giants, and then you've got your subset. So it's pretty powerful to allow you to manipulate, play with the data, find subsets that you really like, get out of the confusing nature that sometimes we can get deep into when you're playing around in such a large parameter space, and then start zipping around. So my next suggestion, if everybody's comfortable to this point with the lasso tool, with creating the plots, with doing the arithmetic, is to let you run around a little bit and look first. I've given you 2 files to play with. My idea is to first step into Gaia DR3 data. So I've linked that file for you in on the website that you should see linked off of the Sagan workshop. So the Gaia catalog of nearby stars matched to DR3. Anthony was taking you through how to do that yesterday. I've already done the matching for you, and it's a nice zipped file for you. Pull it in, and it looked like some people had already grabbed it. You'll notice that you're going to now have an array of new things. You're going to go from 25 or 30, 40 columns in Gaia catalog of nearby stars to, what is it, Anthony? 800 columns. You're gonna get 800 columns, and it's gonna be a lot to play with. So I suggest, if you wanna play with that data, the other thing that you're gonna wanna do is have handy, and I'll put this in the, first I'm gonna open it, and then I'm gonna show you how you can keep this handy. You're gonna want this website, which is the description of all the columns. I literally sit here with this on a regular basis. Maybe some people from Gaia have this memorized. I do not. And so I'm constantly going back and forth to figure out what each column means. And do I want to play with that particular data? So you've got 2 experts, at least in the audience, that know these columns really well, that understand how to play with them, but explore. My suggestion is to explore a couple of the things that you saw this morning: temperature relation, metallicity relation, color code by log G, color code by gravity, or color code by metallicity. And let's see what you come up with, like maybe 10 minutes of that. And then I'll show you a couple of the ones that I play with when I do that. And then ask any questions. I'm going to drop this website in the chat if you haven't already, if you don't already have it on hand. Okay. Oh, Orla, do you have it and you can put it in? I have it here. It's just, for some reason, the Slack isn't showing up on my Slack. Okay, I'll do that. That's perfect. There. It's now in the. So I'll give you maybe like a minute or two more on this, just because then I'm just going to do an ask out to see if anybody has an interesting plot they want to declare. So feel free to, if you like what you've created, or if you have a question about what you've created, I'm curious, since I'm assuming that most people haven't played with the data at a high level yet. And I might be wrong. Maybe some people have really, really played with it, but that's what part of this hands-on is to do. And so I'm very curious what you guys land on in a couple minutes playing. Oh. Let me give Anthony a microphone. Yeah, this is an important difference in how the matching was done. So I played within the Gaia archive and I matched on source ID, and Gaia EDR3 has the exact same positions as Gaia DR3. And so that's what Anthony was showing you how to do yesterday. And so there is a difference in our files. Although yes. So I'm actually not the one that created this particular Gaia catalog of nearby stars match. It came from Gaia DR2, Gaia DR3 hack day, but I'm sure that's the way that we were all doing it that day. So just as a note, there are differences in how you can do your matching. RA index is the same between Gaia DR3, Gaia EDR3 and Gaia DR3 because the astrometry did not update. Clear? Hopefully. Okay. What'd you make? Is this mine? I'm answering. I answered that one. Okay, it's almost 4:30, and so I figured that we would just do about an hour of this. And so does that was exploration time. Does anybody have something they discovered that they want to share out? Any cool plot? Don't be shy. By plotting which? So we got a log G versus T effect. And which log G and T effect did you use? Just so that we can all remember to be familiar with how Gaia has given us many choices. You used which one? GSP phote choice for T effect and log G. Okay, you do have other choices what to use, but great. GSP phote as a reminder that there are others in that drop-down menu that you could play with, but great choice. Cool. Found the red giants that way. Nice. Anything else anyone wants to share out that they found? Did anyone play with something other than GSP phote? Or make a decision why they may have wanted to go to flame, some of the other choices that Gaia gives us? It's okay if you're not sure yet. Any other share outs? I saw a lot of people with cool plots when I walked around, so I know you guys have them. Well, this will be good for the share out at the end because I really wanted to empower you to explore the data at the highest level. You heard a lot of the parameters this morning in how they were arrived at. You'll hear more about them later in the week. There is an enormous amount of information within just that table. And all that table was my grab of the astrophysical parameters table. Anthony described there is more off the Gaia archive. This is where now maybe you'll be empowered to, my niece is calling me. Just say hello to her because this will be weird. Hi, honey. Can you say hi? Okay, I'll call you right back, okay? Okay, yeah, love you, bye. Okay, she's called like she calls every like 20 minutes for some reason. It's adorable. She wants me to play Roblox with her. So at the end of the day, you guys have this tool now. I'd love to see in the when it's time to do the reporting out on Friday, if you want to show off some of these plots that maybe you can get to. This is your empowerment moment. You've got the table, you've got the resource in order to look up what some of these parameters mean. I've matched some things for you. Anthony's showed you how to match to Gaia and pull out things like the parameters for these exoplanets. I don't know, just rediscover the Radius Valley. Eric Mamachek just rediscovered the Hyades. I rediscover the Hyades almost every time I look at the Gaia data set and think I've discovered something new, and then get disappointed in myself. Although that doesn't mean that you can't make a discovery this week. Because remember, this Gaia DR3 data is brand spanking new. So there's lots of room for exploration. Okay, so that's all I think from my hands-on portion of the session. There is another notebook that Anthony had if you want to run through it, or if there's anything more you want to run through on that. Okay, yeah, Anthony, why don't you come on up?
All right, so the first remark is that Orla is still here until tomorrow. So if you have any questions about the astrophysical parameters and what you're plotting, then please talk to her, ask her. And the other thing is, so the answers for yesterday's notebook have already been posted. So the idea for the fourth exercise was that you learn about the fact that inverting parallaxes can be dangerous if the relative error is higher than 20%. So that's why we have distances in the catalog, which are actually inferred from the combination of parallax and the photometric spectroscopic information. And then the fifth exercise is a challenge for the rest of the week. So I've shown you how to do the cross match between the exoplanet archive and Gaia DR3. And what we extracted were the standard sort of astrophysical parameters, the ones from GSP-FOT that are in the main Gaia source table. But there is also this golden sample of FGKM stars that Orla talked about this morning. And the idea is that you use those parameters. So you make a new match against that table. You can start from the already existing match that you have. You just use the source ID to extract the FGKM stars from the golden sample. And that will be less planets, of course, because it's a highly filtered sample. But it should be very good astrophysical parameters. And then indeed, you can try to do things as like re-deriving the radii of the planets with these new stellar parameters. And for example, compare to what is already in the exoplanet archive and see if there, are there any differences? Does it look better, etc. Try maybe to reproduce the plot that Orla showed. So there's plenty of things you can do, but that's a challenge then for the rest of the week for those who are interested in it. And so I'll be interested to see Friday if anyone will report back on that. And there is an additional, sorry, Orla, you want to say something? Yeah.
So there's a question in the Slack about the descriptions of many of the parameters. So in the table that you've extracted, they are the parameters from Gaia source. Okay, so that's a different table than the astrophysical parameter table. So this is why we encourage you to go straight to the Gaia archive, go to help, go to data model, and there you can click on the table that you want to look up. So you can go to Gaia source, you'll get the description of all Gaia source, like RA, DEC, parallax, and then astrophysical parameters, which is what you showed, Jackie. That's another table, okay? So if you want to get the detailed descriptions, go directly to the Gaia archive and click on the right table. I guess you have Gaia source and astrophysical parameters, right, in this data set. I don't know if you have anything else. Yeah. I haven't checked.
Okay. Yeah, so Gaia archive is very easy to find. Just Google Gaia archive and you will find it, and then there you can find all the help, etc. So it's you don't need to store the long link. I mean, you can, of course, if you want to, but it's actually fairly easy to find. So the other thing I wanted to say is that there is an additional notebook on the transiting exoplanets sample in Gaia. Unfortunately, the table of transiting exoplanets has errors in it, and we haven't yet replaced it with a corrected version. So I think it's better. I mean, you can have a look at the notebook in order to learn about how to extract the actual light curves. So that's very useful. But don't use the contents of the table any further. I already truncated it to only the 17 or so first planets to make sure it's very clear it's not the same thing as in the archive. But if you want to work with these transiting exoplanets, wait for the updated version of the table. I hope it comes out over the next few weeks. We already have it in hand. but it's still being validated at the moment, and it couldn't be finished on time for the workshop, unfortunately. So I think we just skipped that. But if you want to have a look at it by yourself, and of course I'm here the whole week. If you have questions, just come to me. Yeah.
I just had one last thing to say on this too, because I'm a user of Gaia, and so we do this thing in New York City where we have a hack week whenever the Gaia drops. And so there were about 55, maybe it was like 70 people that gathered in New York City on DR3 day to learn the data sets. And I just want to say that, you guys are getting a taste of this today. If you've never seen or played with the Gaia DR3 data before, don't be intimidated. We spent 5 days amongst loads of like super immersed heavy Gaia users, not Gaia Deepak team, but Gaia users, like really trying to figure out the data. And there's a lot in there. So like, this is really fun to do, but just know like it's okay if it feels like a little bit like, oh, there's a lot in here at first. You have the help of the Gaia team here. I'm excited to see what you guys come up with. But the experts in the room are the Gaia Deepak people, the people that have worked on the Gaia data. So I encourage you, I actually implore you to talk to them now, as I will talk to them now too, since I'm also a Gaia user that's desperate to make sure I totally understand what's happening there. So please take advantage of that for those of you that are here, and also those of you that are on Zoom, ask your questions. To have these experts of the data with you ready to help for the next couple of days is it's priceless in some ways, especially if you want to move your science forward, because the data is so spanking new and chock full of awesomeness. Make sense? That's my pitch. I feel like this was a good place to concrete wall done, and last announcements from Elise and Dawn, maybe. Or applause.